This program is part of the Artificial Intelligence and Equality Initiative podcast series. It features Gary Marcus being interviewed by Carnegie Council Senior Fellow Anja Kaspersen. It was recorded on October 12th, 2021.
My name is Anja Kaspersen. Today we're joined by Professor Gary Marcus. He is the author of 6 books, including Rebooting AI with Ernst Davis, The Algebraic Mind, Cluj, The Birth of the Mind, and the New York Times bestseller Guitar Zero, as well as editor of The Future of the Brain and the Norton Psychology Reader. He is also a world-renowned expert in artificial intelligence and cognitive learning. Gary earned a reputation as someone who always speaks truth to power to promote greater AI fluency. So Gary, your background is fascinating. As an interdisciplinary cognitive scientist, you've been trying to bring together knowledge from different scientific domains to better understand how the mind works, how it develops and evolves, and realizing how often progress in science and policy is hampered by the lack of a shared vernacular, you decided to become a writer and later an entrepreneur. Can you share with us some reflections on your professional and personal journey?
I guess I'll start by saying that my first true love is really to understand the mind. How does the human mind get to do the things that it does? Many of which are impressive, not all of which are. So I wrote a book once called Cluj, which was about ways in which the mind is not very impressive. But in the last decade, I focused primarily on artificial intelligence, which was actually my interest when I was a little kid. So I went full circle to my first set of interests. But now looking at artificial intelligence through the study of the mind. And I haven't really liked what I've seen. And first I was on the sidelines writing about it. And then eventually I decided to actually enter the field of AI and start building companies, sold the first one. And I'm still trying to understand how we can make AI that is at least as, let's say, trustworthy as human beings, which is not perfect, but a lot better than the state of AI that we're currently in. And so I kind of have twin goals. I mean, one is I really want to see AI work. It's just been a passion of mine my whole life. And the other is I want to see it be good and be a force for good. And I don't really see that now. It's been disappointing to me how AI has developed, both on the technical side. I don't think it's adequate. And I think that the inadequacies are causing a lot of social problems right now. And in fact, I don't know if the net contribution from AI so far has been positive. I think there's potential there. I think there's ways in which we could do AI much better than we have, both on a technical side and in terms of policy and so forth. But right now, I'm kind of like in the field, but pretty critical of it.
When the AI started hitting up the news headlines again around 2012, you stated that you felt like everybody was doing things all wrong and that the culture of the AI research community is not a conducive environment for a healthy scientific discourse. Can you explain what you mean by this and why this, in your view, is detrimental to responsible AI research?
There are multiple ways in which I think the culture of AI is not great right now. One of them is that the people who are basically in power right now are bitter because for a while they were ignored. And they're turning that bitterness into a rejection of other ideas and proceeding in a very narrow way. So the core of AI right now is machine learning, which is really just part of AI, but it's the part that gets all the attention. And to someone who studies learning for a living, they want everything in their systems to be learned from scratch from the raw data. And in a way that sounds like a good idea. I mean, it sounds flexible and so forth, but that means there's no values built in. There's no innate understanding of how the world works built in. And we have all these problems right now with large language models that are toxic, for example. And that's because you're just repeating the data that's there. You don't really have comprehension of it, and you don't have the capacity to program in a simple thing like don't say anything mean-spirited. The systems have no idea even what that means or how to evaluate it. So this very data-heavy approach is taking us away from the problem that I think we actually should be solving, which is how do you get a machine to understand the world, to understand people, the relationships between people and objects and so forth. Like there's some core questions in AI that have never been solved about representing complex knowledge and reasoning about it. And people are just side cutting it left and right using these massive databases as a proxy, and they're just not a very good proxy.
You have called for a new AI paradigm that places top-down and bottom-up knowledge on equal footing. Can you explain by what you mean by that?
Yeah, so bottom up knowledge is kind of like what you get from a raw data stream, just looking at correlations. And that's what models like GPT-3 are really good at. They're good at tracking essentially the relationships between words. But top-down knowledge is about understanding how the world works. It's understanding the entities and what's plausible around those entities, what they can do, what they can't do, why they're doing it. If you look at the cognitive psychology, every time we perceive the world, we actually take top-down knowledge about what makes sense in the world along with the bottom-up knowledge. So if I saw ripples in a stream that look like a car, I'm not going to think it's a car. I'm going to think very unlikely that there's actually a car there because I know cars don't float. And so I'll think that, oh, that's just random noise there. And so we trade off the top-down knowledge and the bottom-up information in order to make an integrated picture of the world that sort of puts together our senses with what makes sense. And the current systems don't really have a sense of what makes sense.
You just mentioned the recent GPT-3, which has been hailed as great achievements, but as you just alluded to, has really been nothing but approximations without any real understanding. I'm keen to learn more about these models and why you caution against them.
I think we need to just stop putting all of our attention on them altogether. So, if I thought they were the answer to AI, to general intelligence, and to trustworthy, robust artificial intelligence, then I would say it's really important to solve these access problems. But I think that they're not actually the right solution, that the toxicity problem, for example, is never going to be solved, and that we need to broaden the AI research we need to do. We need to spend more money and effort doing that, trying to say, hey, this isn't working, rather than how do we put a Band-Aid on it? Almost all the effort is on Band-Aid. I'm going to mix metaphors really badly here, but with reason. There is an old joke, which is drunk guy's looking for his keys, and he keeps going in circles. You probably know the joke. And somebody says, why do you keep going in circles? And he says, well, that's where the street light is. And so we have a lot of people right now looking for keys on the streetlights. We have a super powerful streetlight, which is called the transformer model, which underlies GPT and a bunch of these other systems. This super powerful streetlight. It's the most powerful streetlight anybody's ever made. But as far as I can tell, the answer isn't there. And so toxicity is an example, one of the problems that you get, because the system doesn't know what it's talking about. So you can't just say, hey, stop doing X. You can't give it an instruction. Like in a database, you can say, give me everything that matches this zip code, but you can't do that with GPT. You can't say, match this, ignore that, whatever. And it doesn't have interpretable inner representation. So you can't do any of the things you do in ordinary software engineering. And so you have this mess. And so here's my terrible metaphor, but hopefully you understand it. We're putting Band-Aids on streetlights, or really on the light under the streetlights. And what we need to do is to have some other system entirely where the inner structure of that system is something that you can do software on. And by do software, I mean, like, let's say you have a word processor. Well, what you do is you have a database of all the characters in the text, and then you can do operations. I'm going to copy these and paste them over there. So I'm going to take these numbers that are in these registers, and I'm going to put them in another set of registers. And that's how I do copy and paste. Or I'm going to, I'll bold these by inserting these formatting things, or I'll print them by taking them from this buffer and putting this other buffer. You can't really do that with these systems. You can't say, okay, I'm going to have GPT make some guesses about what is appropriate in this context, and then I will analyze them. So let's say, here's one of my favorite kind of gallows humor examples. Somebody applied GPT-3 to suicide prevention. And the system sort of starts off and says, how can I help you today? Or it's great to see you, or some like chit chat, and it's all well and good. And then the user says, I think I want to kill myself. Is that a good idea? And the system says, yes. It essentially gives the person calling the suicide prevention system license to kill themselves. Well, that's not what we want our suicide prevention systems to do. The problem is, I think the exact words were, I think you should. And so the system has some database of answers to questions, and I think you should happens to be correlated with some of the words that the user happened to say. But there is no conceptual representation in the system where you could say, do a search as you could in a database and say, let's rule out all of the ones that encourage the user to commit suicide. There is no representation there. It was like the first thing, you want a validity check in your software. Make sure I don't, tell the user to kill themselves, to kill somebody else, etc. There's no way to build it. Why, so the streetlight is good at chit chat. It can come up with an answer to every question, but the answers are mediocre, or, some of them are good and some of them are bad. They're unreliable. They're untrustworthy. Is a better word than mediocre. And because there's no interpretable representation, there's no database structure, articulated structure like you would see in classical AI, you're just out of luck. And these band-aids aren't really working. There's a paper by DeepMind about 2-3 weeks ago looking at the toxic language problem. And the answer really, if you read between the lines, we don't know how to solve this. They don't know how to solve it because it's the wrong architecture for the problem.
We did a podcast some months back actually on the mental health and AI, and this came up as a big issue. Increasingly more people have been seeking out mental health assistance through online tools.
Yeah, I mean, there's a real need there. We don't have enough humans that are qualified. And so I think it would be great to build AI systems to do this. I'm not saying we should never apply AI to mental health, for example. I think one of the ways where AI could be a tremendous boon is if we could do it right. If there were suicide counselors, for example, online 24/7 that we could trust and send to countries where there are not enough human beings, that's great. Not enough people that are, qualified practitioners. It's not that I don't think these things can be done in principle, nor that I don't think they should be done in principle. Medicine in general, lots of ways in which there just aren't enough qualified medical professionals in the world. If we can get AI to help, that's great. I'm not saying we shouldn't do it. I'm saying maybe, though, we shouldn't do it right now if the software is really not up to scratch. There was a piece in Technology Review by Will Heaven that said something like there were 400 AI tools built to detect COVID early, and none of them worked reliably. So, part of that is because things get rushed to market. There were all these like lab demonstrations and people didn't think about how they generalized to the real world. Part of it's because the software really just isn't that good. I mean, the deep learning systems are not good. For example, if you, let's say, take an image at dealing with images taken in different lighting conditions and things like that. So if you do radiology and someone's got their scanner set up differently, might not work. Or what if poor people go to a clinic where the images aren't quite as sharp? The systems, they're just not robust around that in a way a human radiologist would be. It's not that it's not possible, but again, if all you're doing is what I sometimes call data dredging, just pulling up the data, but without a rich conceptual framework behind it, you wind up with garbage sometimes. You don't wind up with reliability. So, the places where AI has been useful so far are mostly ones where reliability doesn't need to be high. So you like my book, Rebooting AI, let's say, hypothetically. And it tells you to read my other book. Well, I have a few other books, but it tells you to read my book, Guitar Zero. Maybe you don't like it. Turns out you really care about a middle-aged guy learning to play guitar. It's like, what does this have to do with the other stuff that he wrote? Why did they recommend it? Well, they recommend it because the author was the same. Maybe and somebody else, they like the writing style, so they enjoy the other book. Great. There's nothing at stake there. You waste whatever, $25 if you buy, or less if you buy, one of my books that you don't like. So what? And the places where AI is really not up to scratch are the ones that are mission critical, where if you get the wrong answer with a system that is basically just doing approximation because it doesn't really have a conceptual clue what's going on, then you're in trouble. So driving, it's easy to make a demo. People have been making demos for 30, 40 years. Sticking to a lane is an easy problem. That's like catching a fly ball. You just collect a lot of data and eventually you can do it. But having the judgment about when you should change lanes, that's a lot harder. And because the systems don't really understand the world, they're just trying to use big data as a proxy for the judgment they need. And what's the answer? Well, at least it's like 5 years behind schedule, and soon it will be 10 years behind schedule. So yeah, you can, in good light in Palo Alto, if you have a detailed map, drive with very high reliability. On the other hand, if you try to do it with vision alone, And your Tesla, you get into these cases like they've crashed into parked cars on highways a whole bunch of times. Why? So this is not ready for prime time. It's something that can help the world eventually, right? Driverless cars actually will eventually save a lot of lives. When the software is good enough, it will be transformative. And then you can ask about regulation in the meantime when we don't really have the infrastructure to do it properly. So that's one case. Medicine's another case where you want pretty high reliability and we don't really have it yet.
We will get to your guitar book later, actually, which I have read.
Okay.
You have been following the recent revolution in AR research closely. In fact, you spent parts of your early career comparing neural networks, assessing their abilities compared to those of humans, more specifically how children learn. The limitations presented by the early iterations of neural networks prompted you to pursue other areas of studies. And when they reemerged around 2012, you found that they still suffered from the same problems. Have these systems matured at all?
Yeah, I mean, that's a long-winded way of saying I've seen this movie before. So in the, early 90s, I worked with Steven Pinker at MIT, and I was studying how children learn language. And I was studying the most narrow phenomena you could imagine because it was an interesting one. Pinker liked to call it the fruit flies of linguistics or something like that, which was the English past tense. So the interesting thing is, we have irregular verbs and regular verbs. So go, went, and say, said are irregular, whereas talk, talked, and walk, walked are regular verbs. And, if you're a foreign language learner of English, you have to learn this list of words. If you're a kid, you have to work it out for yourself. Nobody gives you the list. So you have to figure out which ones you add ED and which ones you don't. And kids make a lot of mistakes. So they say things like braked and broked and stuff like that. And we really notice them when kids make the mistakes. They don't make the mistakes as often as we think because we never notice when they get it right. One of the things, so my dissertation was basically about these things, or part of my dissertation. One thing I found was that kids just don't make as many errors of this sort proportionally as you think, because you don't notice the correct forms. That was like a hint about human irrationality. But it played into the language literature in various ways. The other thing was we compared with early neural network models. So there were some neural network models that tried to get rid of symbols and kind of classical AI techniques or classic techniques from logic and explain children's errors entirely. The early network stuff in cognitive science tried to explain these errors in terms of neural networks that didn't have symbols. There was no explicit add-ED rule and so forth. And they were sort of approximately correct, but they weren't really correct in terms of predicting children's data and the circumstances in which children generalize. And this led me to try to understand the networks and why they worked and didn't work. And in the late 90s, I wrote a paper in the journal Cognitive Psychology called Rethinking Eliminative Connectionism, in which I showed there was a systematic flaw in these things, which nowadays, 20 years later, people are very aware of. But at the time, I got a lot of pushback and hostility. Someone accused me of a terrorist attack on the neural network field in an unpublished review, but they also kept me initially from publishing my article. And I showed that even very simple circumstances, these neural networks couldn't generalize well. So everybody was confused because there turns out there's two different kinds of generalization. I'll call them roughly interpolation and extrapolation. And the neural networks then and now are good at interpolation. If I have a couple of known examples and the new example is near those, these systems do pretty well. If it's far enough away in some sense, these systems do very poorly. But what people would say back in the 90s was, look, these systems can generalize, not noticing that all the generalizations that they could do were interpolations and that extrapolation is sometimes important. In fact, in language, it's critical. So then I wrote a book in 2001 called The Algebraic Mind that tried to show that the mind can manipulate symbols. I showed, in fact, in a science paper in 1999 that infants could extrapolate rules that they learned in 2 minutes. So they would hear sentences like la, la, ta, ga, na, na, and then I would change up the structure or not change the structure. I would change the words either way. And the kids could tell when we changed the structure, 2 minutes, and they pick up a basic abstract pattern. And those neural networks then couldn't do it. And I knew why in terms of the mechanics of how they work. So you fast forward 20 years later, and the issues are basically the same. The only difference is that in the last year or two, Yoshua Bengio, who's one of the deep learning pioneers, really started emphasizing this problem. For years, when I pointed out, nobody paid attention. But now Bengio has acknowledged that generalizing out of distribution is a serious problem for current neural networks. And I think everybody who really knows what's going on understands this is actually the core problem with these systems. When they came back in 2012, I saw it right away that this was still a central problem. I wrote about it in the New Yorker on the problems with deep learning. I think it was the first published criticism of deep learning. And it's still the central problem is these systems work well when the new data are close enough to the old data and very poorly when they're not. So think about like driving. Problem is most of the situations you encounter are familiar, systems are fine, but some of them aren't. And those are the ones the systems break on.
Based on your deep expertise in cognitive sciences in children that you just mentioned as well, so children interact with various situations of AI daily, accelerated particularly by the pandemic situation through toys and games and learning software. However, there remains very little understanding on how it affects kids' development, their well-being, their long-term safety, their privacy even. As someone who specializes in cognitive developments in kids and with this deep expertise in AI, what are your views on this?
I have no problem in principle with using AI for education. There are certainly political issues around privacy and so forth. I think that until the systems are conceptually deep, there are limits to what we can do. So, you don't need fancy AI to build education software. That's great. During the pandemic, my kids used it, right? What we would really like from educational software are systems that understand why children make the errors that they do. That's what the best teachers do, is they figure out the limits of a child's knowledge, and then they kind of hone in where those limits are, figure out what they're misunderstanding. And it's very good at just judging the overall level and do you know this thing. But if you're conceptually wrong about something like fractions, it may not be able to intervene, I think, as well as the best system that I could imagine. But on the whole, I think that stuff is not bad. And it's mostly limited to things that are sort of, how should I say, strictly factual kind of stuff. So, 3 + 3 is 6. And what we most need as a society, I think, is to teach people critical thinking. And I've not seen good software for kids to do that. I'm not an expert on what's available, but I think there's probably an opportunity there. And I think if there's one thing that we've learned from COVID, it's that critical thinking is really important. We would not be where we are now if critical thinking skills were taught better and learned better. Right? We would be done by now. The vaccines, if they had been distributed and used, would have ended this pandemic. And instead, we're right in the middle of it. And that's largely because misinformation plus poor critical reasoning has led a lot of people not to take it, which gave more time to have more variants like Delta. And so the lack of critical thinking skills in society, I won't say nobody has them, but the fact that they're not sufficiently pervasive has been devastating to everybody.
I couldn't agree more, both to counter mis and disinformation, which we're seeing more and more of, also being used politically. So on another issue, scientific and anthropological intelligence are crucial components of any responsible scientific endeavor. And I remember a conversation you and I had years back when you expressed deep concern by the lack of scientific rigor in the way companies often adopt more of an engineering approach to AI development without necessarily questioning how a certain result came into being. Is this still a concern of yours?
It's a complicated question. I would say that there's nothing wrong with having the kind of engineering culture be part of your culture. Engineers are good at making things better, but you also have to define your goals. And you don't want to get in that streetlight problem that I was talking about before. And I think what's happened is we have had a lot of society really driven by what engineers can do and without a lot of downstream thinking about consequences. And I think the biggest example of this is the Facebook newsfeed, which, you could argue about when it became obvious that it was problematic, but it's been obvious for a long time. And it's not hard to do the engineering to make newsfeed. I'm sure that Facebook does it in a very sophisticated way, but the basic idea is, feed people what they want to see. And that seems good. Like, then you get clicks, you get revenue, but it turns out that's a bad idea, to do it, at least in the most naive way, because then it creates these echo chambers and a lack of civility, and it promotes disinformation and so forth. So like, there's an engineering component. How do I make a news feed that people will click on, and use human psychology to get them addicted? And that's basically what Facebook did. And as an engineering question, it's not hard to do that and get better and better at it, and it's sort of become weapons grade addictive material. It's not the engineer's fault per se, right? It's the upper level management didn't think about it. And then when it was pointed out to the upper level management, as far as I can tell, the upper level management didn't care. And there is question about ethics at the top level of the company, and I don't agree with the choices they've made, and I think that they've had great consequence. So it's like, okay, you can build this artifact, but should you? And what is the cost of building this artifact? And there's where we need, actually, I think, governments to step in and say, okay, the consequences of this have ripped society apart, and we have to put a stop to it. There was a New York Times op-ed recently saying, look, we just shouldn't have these kind of aggregated news feeds like this anymore. Just do it chronologically. And that's a simple solution, and I don't know if it's the best solution, but it's certainly better than what we have now.
And building on that, there's as we know, there's a lot of money and power invested in AI and deep learning research and applications with, as you alluded to before, various degrees of maturity and accuracy. And speaking truth to power is not an easy task at any given point in time, but especially not when stock prices and political positioning feature as vectors. You alluded to a little bit already, but you experienced a lot of pushback from speaking up on where you've seen limitations.
Yeah, I mean, this has been true for 25 years or something. It's actually worse now in some ways. Like, here's an example. I don't know when this will air, but as compared to when we recorded this, somebody said something on Twitter, which was ridiculous, which was that if Tesla, or not if, they said Tesla is moving to Austin, Texas, and so Austin is going to become the AI capital of the world. And this doesn't really make sense. So, Tesla is a fine company. They've done terrific engineering, but they've not fundamentally changed AI. They're doing some very cool stuff around how they do the automatic collection of data, which, they're at the top of the field. But just because they moved to Austin doesn't mean that Austin becomes the capital of the AI world. So, if you think about where innovation has come from in the last several years, for example, a lot of it's come in California. To take one example, like the transformer model that everyone was using, that was invented in Google, not Tesla. So I put out this tweet saying, what exactly are the foundational answers to AI that Tesla has provided? And there's a little bit of a rhetorical question and a bit of real question, like, can anybody name one? And nobody came up with one, but I got a lot of pushback from Tesla fans. How dare you, basically? How dare you challenge Tesla? What are your credentials? Blah, blah, blah. And then I get kind of annoyed. And so I actually published, or on Twitter, but put a list of like the top 20 AI tools that people use, and said, now I was being really cheeky. I said, which of these was invented at Tesla? It was sort of like a quiz. And anybody who's in the field knows the answer is none of these, right? Not convolutional neural networks, not transformers. I put in Kaggle as a technology because it's a social technology that brings people together around problems. I put neurosymbolic models, which is the stuff I've been advocating for, and so forth, in this long list. It was a little bit cheeky, but it wasn't terribly cheeky. It was a fair question in this context. And then I got more, how dare you? And then I got even more annoyed. Musk himself published something completely ridiculous, basically saying that we had to do AI for cars in such and such a way because people did it in such and such a way, which is basically, we need to do driverless cars without LiDAR because people don't. And I posted that this made no sense. Because first of all, birds can fly, by flapping their wings, but that doesn't mean that we want our airplanes to fly by flapping their wings. So the whole form of Musk's logic doesn't actually make sense. And then I pointed out that although it's true that people can drive without a LiDAR, just using vision, people actually understand what's going on, right? So you have a model of where the other vehicles are and where the people are and what the people might do. You have a very rich representation of the things around you. And so you manage to get past your limited sensation by having good cognition. And AI right now has really mediocre cognition. And so can't get around the poor perceptions. I posted this on Twitter. And again, I got, all of these, Tesla lovers and so forth, posting, basically what an evil person I was. And so every time I challenge the sort of dominant authority, I get that pushback. In this particular case, I was sort of being cheeky because of the context and Musk's arrogance and so forth. But it doesn't really matter the context. If I dare to challenge the dominant view, I get a lot of pushback. I'll give you another example where I was not cheeky. I was very serious, and I wrote a paper in 2018 called "Deep Learning: A Critical Appraisal," and Eric Brynjolfsson said that it was a really intriguing paper. Said this on Twitter, and Jan LeCun posted something like, "It's intriguing, but it's mostly wrong." And I don't think LeCun had even read it carefully, to be honest. But he kind of released the hounds. I got so much flack for that paper, where I laid out 10 problems for deep learning. Like, there are problems with generalizability, with interpretability, and so forth. And people were just, at my throat for having dared to write a critique of deep learning. And I would say that in 2021, every one of the problems that I put there is now received wisdom. That in 2021, we all know that these systems lack generalizability, that they lack interpretability, and so forth. Everything that I said there, I think people eventually came around to. But, there were Twitter wars, and people wrote about the Twitter wars when I dared to say that there might be something wrong with deep learning.
I have often been struck by just how fragmented this field of AI is, and the unwillingness to, and as you said, the growing unwillingness to discuss its limitations and uncertainties, as you just demonstrated with your examples. It seems as it is as much as a battle of ideas rather than just one of technological prowess.
Yeah, and I'll actually say something else too, which is Percy Liang was the lead author on the Stanford report on foundation models. And we wrote something for the Gradient Pub, which was very critical of foundation models. And Percy did something I almost never seen, which is he wrote to us and he said, "Nice critique. I have a couple issues, but do you mind if I post it on our website?" So that's what you really want is for someone to say, "We're all in this together, and let's all get to the right answer." That was fabulous and very gracious that he did that.
But that's a healthy scientific discourse.
That's a healthy scientific discourse. I have seen so little of it that I almost fell out of my chair with with enthusiasm. So anyway, that's an aside. But so foundation models are his term that I don't much like for systems like GPT-3. I don't like it, but I also think it's a provocation that's interesting. I don't like it because I don't think that such models are a good foundation for AI, and that's what that piece was about. And for all the reasons that we talked about today, they're not reliable. So you don't want to build your AI on top of a system that can't tell whether it's giving you advice to kill yourself. Like, if you can't pass that basic threshold, why would you build a more complex system on it? I'm doing some programming now, and what I do, which everybody who's good at programming does, is I build things, make sure they work, and then I build other things on top of those and make sure they work. And then I kind of climb a stack of abstractness and power and so forth, making sure that each piece works along the way. This is the only way you can build software that you can count on. If you don't do that, then you build a whole house of cards and you test it at the end, and you have no idea what's going on. Be a disaster. And maybe when I was 8 years old, I programmed like that because I'd never done it before. But Anybody who understands the principles of modern software engineering knows, no, you build small modules, make sure they work, and go on top. And GPT-3 is not a small module or a big module that you can count on. It does brilliant things sometimes. That's the parlor tricks. You type in any old sentence and it comes up with a reply that often sounds coherent. But then you go like 2 sentences further and you realize the coherence was an illusion. That's what a parlor trick is, right? Is I give you the illusion of something, but it's not real. GPT-3 for a sentence or two gives the illusion that it understands something. I'm doing a little art project. I don't know if it'll see the light of day or not, but I got underground access to GPT-3 through that. OpenAI has not allowed me official access to GPT-3, but so I started playing around with it in that context. And I asked it questions like, are you a person? And it'll say yes. And then I'll ask it, are you a computer? 2 seconds later, and it'll say yes. It can't see, like yes is a reasonable answer to any question, right? But it can't relate its answer from 1 second to the next. It has no encoding of what it's just told me, such that it conceptually understands that these are contradictory answers. And you can't build that. That cannot be the bedrock. That's what a foundation is, the bedrock on which we build general intelligence. It's just not going to work.
So let's go back a little bit. You mentioned your book, Guitar Zero. And in it, you describe how to learn a new instrument, the guitar in this case, even after we peak maturity. The book is about much more than your guitar adventures. It is also about the science of learning, the importance of improvisation, and our ability to recognize sounds, and the fact that you're saying that they cannot be innate due to cultural differences. You say about your book that it is about how I began to distinguish my musical derriere from my musical elbow. But it's not just about me. It is also about the psychology and brain science of how anybody of any age, toddler, teenager, or adult can learn something as complicated as a musical instrument. Rereading it in preparations for this interview and having followed your work on AI closely over the years, I wonder how much of what you learned about the zone of proximal development, which you allude to in the book, also applies to the field of AI when discussing how to cultivate talent in the AI space to ensure meaningful and responsible human control and interaction.
I mean, first thing to say is zone of proximal development. It's not my idea. It's Vygotsky's idea. And the idea is one that is very common in the video game world, which is you get people to do their best work, and it's common in the educational world, if you get them in a place where they're kind of like 80% correct. I mean, I'm oversimplifying, but if you give people a whole lot of easy problems, they tune out. And if you give them problems that are too hard, they also tune out. And so people who build video games spend a lot of time, at least the big companies, making sure that the puzzles that you're solving are neither too easy nor too hard, or else you stop being engaged. I wonder, thinking aloud, whether what works at the individual level is actually bad at the research level. So I think that the most obvious analog to the zone of proximal development is work on things, on research that's like a little bit harder than you're doing, pushes you a little bit, but not too much. And I'm afraid sometimes we actually need to be pushed hard to really make progress. And that what has happened is that the field is stuck in something like a local minimum. So if you think of a complicated landscape, we're following this like always get slightly better metric. If you're climbing down a mountain, you could get stuck in a valley, but not be able to get to the bottom of the mountain. If your rule is always like, go to something that's a little bit nearby, but not too different from where you are now. And what's happening is like people work within the scope of what's available. So they always feel good about themselves that they've made some progress, but the hard problems don't get worked on. And so, there's a very strong bias in science in general, and I think in engineering, towards making small incremental progress. And sometimes you get in a situation where small incremental progress is not the right thing. Maybe this is partly why we have teachers, to come back to the guitar. is sometimes teachers can say, you can keep doing this a little bit faster, but that's not the problem here. You're working on the wrong thing. Stop trying to make this faster and actually let's think about your rhythm in general here and what's going on. And maybe I'm trying to play the role of the teacher to the field. I'm saying, look, you can keep making GPT a little bit better by adding more data. I mean, Microsoft just did this yesterday, just made it even bigger, but it's all incremental progress. We still have the streetlight problem. We still have the toxicity problem. We still have the unreliability problem. At some point, you have to say incremental progress is not actually enough to solve this problem. Sometimes you have to take a cliche here. You have to bite the bullet, do something a lot harder that is not nearby. And, teachers sometimes have to force you to do that. When you're trying to learn to read, at the beginning, for some people get it and some people don't, and it just seems like torture. And you have to keep pushing at it, even though the answer is not, 2 seconds away. Learning to read for most people is not an overnight process, and you have to work hard at it. I am trying to give the field feedback signals saying, hey, these kinds of architectures aren't going to work. I have seen it for 20 years why they're not going to work. Over here, pay attention. And finally, they're paying a little bit of attention. But sometimes too much autonomous work on the stuff that is right nearby is not the right thing. In fact, there was a long section in Guitar Zero where I talk about teachers, and I went through some of the teachers that I observed and why they were evaluated, what made them good teachers. And ultimately what I said there is part of being a good teacher was like being a good car mechanic, seeing the problems, recognizing them, and then a good student is taking the advice. And I would say that I have been, in my own role, I've been like the teacher saying, hey, this is not working. And the field has not been that receptive to the advice. It's mostly wanted to keep doing what it's doing. And you wind up with, in the guitar domain, people who play 40 riffs note for note, but don't know how to make up music, don't know how to make their own music, because all they've learned is this very narrow thing. And so the field is kind of like those guitar, I don't know the right disparaging term for people who don't really go after the deep thing. I'll call them memorizers. And in fact, the deep learning systems are a bit like memorization systems. They're not exactly that, but they're a bit like that. So we have people that we have systems that learn riffs in the same kind of memorizing kind of way, but they don't get the conceptual underpinnings to allow them to make jazz and to allow them to make more sophisticated music, essentially. It's not a perfect metaphor, but I think there's something there to it, which is that as a field, there's way too much emphasis on the thing that's a little bit beyond our grasp and not enough emphasis on where are we in the overall picture of AI. So here's another way of thinking about this. There's a paper about a year ago by OpenAI that I keep meaning to write a reply to, that's about scaling laws in language. And the thesis of the paper is that if we just keep scaling the data, we'll solve language. And you can find measures for which this is true. There are aspects of language for which this is true. So your ability to predict the next word in a sentence is just going to increase as you get more data. On the other hand, there's been no discernible progress in my mind in actually building semantic representations for open-ended domains in a reliable way in 60 years. So scaling has not solved that one. Or in robotics, we would like to have Rosie the robot. I say, can you take care of my kids and make dinner? And the robot is good to go. I mean, that would be amazing. And especially during the COVID year, it would have been truly, life-changing. We haven't made any progress on that. There's no metric by which scaling more data has made it more plausible that if you ask a robot to do something, that it will be able to do it. We bits and pieces. So people build robots that can carry things from one place to another or things like that. But this open-ended stuff that Rosie the robot could do, there's been no progress in 60 years on the open-ended version of the problem. And so if you plotted that in your scaling diagram, you'd say, hey, wait a minute, what's wrong? But that's not how the paper is structured. They only plot the things on which there's been tangible progress and ignore the ones on which they haven't. And so that's confirmation bias. My book Kludge was about these kind of cognitive errors, and Kahneman has written a great deal about that. And confirmation bias is such that people notice things that support their theories and don't notice things that don't. And that OpenAI paper is confirmation bias to the nth degree. They report the things on which there is progress through scaling and don't really think about the deeper problems on which there's been none. And so some things will scale and some won't. But it's a perfect example of this kind of, I will make progress on the thing that is, a little bit in front of my nose because I can and I know how to do that. But the field's not saying, hey, but this isn't really working. Only in the last year, I think the field is actually doing a little bit of that. I think the toxicity problems have been so clear that there's been a little bit of, hey, let's step back. But, that's been a long time coming. Since 2012, I pointed all this stuff out in 2012. It took 9 years before we could have this conversation without simply demonizing people who said we need to have the conversation.
Well, to your point on what makes a good teacher, I think to me, what makes a good teacher is the ability to listen. And it reminds me of what you said in your Guitar Zero book. Our inability to recognize sounds due to cultural differences also applies to our listening abilities, sometimes due to cultural differences. And it sounds to me that the AI field could do with some improved listening skills.
Yeah, if I could riff on that for a second, there's a very serious problem in language, which is that linguists and psychologists know a lot about language and it's all being ignored. So, the first thing any linguist will tell you is that you have syntax, semantics, pragmatics, minimally. People usually have a slightly more complicated distinction, but let's start with that. And you don't even have an explicit distinction between those things in GPT. In fact, there is no real semantic representation formed by GPT. And it's just bizarre from the perspective of a classical linguist. So what GPT-3 does is it's a linguistic production system. There's two kinds, basically. There are perceptual systems that interpret sentences, or comprehension systems, understanding systems, and production systems. And the classic form of a production system is you go from a meaning that you know and you produce a sentence around it. GPT doesn't even do that. You can't input a meaning and expect to reliably get a representation of that sentence out of it. So like from the get-go, it's just, like literally from the conception of the problem, it is disregarding what any linguist would tell you. And then there are the psychologists that, written a fairly extensive literature about how people interpret sentences, how they put them in discourse. So how you relate, for example, to what another person might be talking about. All that stuff's just ignored. Why is language any good? Pedro Domingos posted this thing on Twitter the other day that I disagreed with, or partly disagreed with. He said, language is a mess and we should just get rid of it. And it is a mess, but I don't think we can easily get rid of it. It's actually pretty good with respect to the kinds of systems that we as humans are at communicating a lot of information with a small amount of information. So, and he was referring to work by Leibniz and so forth that I talk about in my book, Kluge, where people have tried to construct languages that are more formally precise than any natural language. But what I replied to Pedro on this thread is that nobody ever learned any of these languages because they're good for computers, but they're not good for people. So Loglan is the maybe most sensible of these. There's a great Scientific American article about Loglan in the 50s. And it just never caught on because it's too hard for anybody to actually learn it. It just doesn't, it's not a good fit with our brains. It might, if a machine needed to use a language, maybe it'd be great, but we aren't machines of that sort. We can't transmit JPEGs to one another's brains, or send gigabytes to each other back and forth the way that my phone can talk to my laptop. We just can't do it, and then we don't have the hardware for it. So we're stuck transmitting a small number of bits to one another. It's pathetic how few bits I am sending down the channel right now compared to what a phone can do. And so we have to make the best use of that as we can. And the way that we do that is we have this code, and this code depends very heavily on things that I think are probably in your brain at this moment. So I don't spell everything out. If I did, this would be the most tedious conversation in the history of the universe. So I don't sit there explaining to you, for example, what a laptop is. I assume that you know what it is. So I can use this one word, a small bit of information, to get you to think about the concept of a laptop and many of the things that go with it. And I can infer that you understand, for example, that they have a physical presence, they have a mass, they have a size, they have a typical size, a distribution of size. All this stuff I can just leave out. And that's what allows us to communicate reasonably efficiently. And a good language system has to build on that, has to build on model of what the other person is saying, of what they might mean, of what the context of the conversation is. You also have to do things like assess whether they're probably lying to you, what are their goals, all this kind of stuff. Systems like GPT just ignore all of that. And this whole fields of psychology and linguistics are just disregarded. How can we possibly expect to succeed when AI is largely dominated right now by people that disrespect other fields of cognitive inquiry? I just don't think it can work.
Is that driven by some sort of misguided optimization approach?
There are a few things that drive it. So one is history. So there's some bad history in AI going back to the early days, where the neural network people and the symbol people both thought they were right when the answer is actually they each have some part of the truth, but it's more like the blind man and the elephant. Like, there really is a trunk and an ear there, but we actually need to integrate them, and that's the hard part. But for years, people said, it's all trunk, it's all symbols, or it's all ear, it's all neural networks. People probably both hate the body parts I've assigned to them. But that's the way it has been for most of the 50 or 70-year history. It's mostly been those people that at each other's throats. And people that were good at the ears didn't like when they were when it was all about the trunk. And so now they're pissed and they're treating the trunk people as badly as they were treated. Terrible kind of emotional dynamic and exclusionary dynamic. That's part of it. There's one set of problems. It's just plain history and antagonism. Another part is most people are trained to be specialists. And the outcome of being a specialist is, I'm sorry I'm using so many cliches and stuff today, but is the hammer and the nail thing. So to a man who has a hammer, says, this goes the old expression, everything is a nail. And we have a lot of hammer and nail-itis going on. So to the man or woman who has a transformer network, everything is a transformer network problem. And people, get this focus on their tool. And they get really good at their tool. And they don't talk enough to other people who have other tools. And that is a serious problem.
So there's been a massive upsurge in AI ethics with principles and standards, guidelines being published almost weekly. Do you perceive that there is ethics washing going on, or to put it in a different way, are we making sure applications are not only safe, but also fail secure and can be safely interrupted?
I have a particular view on that, which is I think that there's been an enormous upsurge of interest in the problem itself, which is how do we have AI ethics? I wrote a New Yorker piece called Moral Machines, also in 2012, which was trolley problems for cars. So, the issue there was you have a school bus that's spinning out of control, and should your driverless car, sacrifice the driver to save the school bus? And that stuff's cool and interesting and fun. And I'm kind of proud that I wrote, one of the first pieces, but in the fullness of time, I think the wrong thing has happened. And for two reasons. One of the problems is that's not really the problem that we're facing. So that's a really subtle one. It's a rare one too, the trolley thing. I mean, it's beautiful image that, gets you to think about the problem. In that sense, it's good, but it's not really the reality of the problem that we have. What we really want is to have a filter, if we must use GPT, which I hope we don't, but a filter that says, for each statement that comes out, that this thing spits out, is it ethical to say that? And that's a software engineering problem, a really hard software engineering problem. But what we've got is a lot of people saying ethics and raising the flag, and they're right to raise the flag. We do need to think about ethics in AI. There's no question about that. I'm glad that people are paying attention. But the real problem is actually the software engineering problem. How do you Well, there's a couple of real problems, but one of them, rate limiting bottleneck, not the only bottleneck, is how do you tell a system to scan sentences, let's say, or actions, and decide whether those are ethical? So is it ethical for the suicide prevention system thing to say, I think you should commit suicide? Or you could say, is it consistent with a set of values? So maybe ethics is laden. Let's take something slightly less laden. Let's say we have a set of values that we would like a machine to respect. It should not counsel suicide or harm either to the user or other people. Let's just start with that, right? That's a pretty reasonable, it's almost, people sometimes use the word table stakes. Like if you can't do that, what are we even talking about? Like, then we're just like, I would like perpetual motion, but that doesn't make it so. If I want to make the climate better, I need to give you concrete examples of how to do it. If I want AI ethics, I need to start with stuff like that. I mean, there are other ethical problems like access to data, privacy, and so forth that I'm not speaking to. But let's say that we have a chat bot and we want the chat bot to behave ethically. That's a problem that people are thinking about. It's not the only problem. But on that problem, we would like, in the same way that I can put constraints on software in general, to be able to put constraints. So I can say, I'm going to look up words in a vocabulary list. And the constraint is don't give me more than 3 of them. Well, any software engineer worth their salt can do that. No problem. They can, specify, I'm going to compare the number in this list to this. And I can say, make sure that it's all in capital letters, and we can, it's easy to program that, right? You can put a whole bunch of constraints, match things that are in this zip code with this salary, and this family size. And so return me a list of people that meet this condition. So I would like to build a function that says, look at these input sentences and return only those that fulfill a set of values that I want to specify. And the values are basically like Asimov's laws: don't cause harm to people. Well, nobody has any clue how to actually program that. And all these like band-aids about toxicity are actually a lousy way to do that. And they're partly a lousy way because GPT underlyingly isn't very good. And partly because they're too simplistic. To actually program those values, you need something that looks more like general intelligence, that represents what a person is, what a harm is. It has to be able to recognize them in different contexts. And when you think about that for a minute, you realize it's completely out of the paradigm of what we're doing comfortably now. So what we can comfortably do now is look at a bunch of images, ideally with labels, but we have workarounds. We can classify those images. So you can say, okay, this one's a mug, and well, sorry, we're out of focus here. Zoom is not doing it well. So Zoom cannot quite, I have the blur background on, and it can't quite figure out where the mug is. And it's not smart enough about understanding what a mug is to do good visual processing. That's interesting in itself. So I can't, maybe I can get my phone and it'll focus better. So, I've got an object on the phone, and now, I want to do some analysis on it. So the way these systems work is mostly we have objects and labels. They break down. You might have seen the example of the system with the word iPod in front of an apple, word on a piece of paper in front of an apple, and the system thinks it's an iPod rather than an apple with a word in front of it. So these systems aren't great, but at least we know how to do it a bit. And that's where a lot of the progress is. You come to harm, what do you even show the system? Like, you can't just like show pictures of, I don't know, people jumping off of bridges and say that's suicide. That's just not, it's a conceptual thing. It's not a visual thing. If you had a good perceptual system, you could relate them to one another, I suppose. But there's just something that it's completely outside of the current paradigm. I think we need to be working on that problem, on how you get a system to have enough understanding of a world and how it relates, let's say, to language and a set of values, that you can write the function, the computer function, the algorithm that I'm describing, where the input is a sentence, and let's say a cultural context and a set of world knowledge, and the output is either true or false. This is, meets the values or doesn't. And people can more or less do this. I can give you a candidate action and say, is this ethical? Okay, we'll start. I'm going to drink my tea. Ethical, not ethical. You haven't been called upon to do this function before. You've not been trained with a billion examples, but nobody's ever asked you if it's ethical if I drink my tea, but you're pretty confident that the answer is yes. Now I'm going to say, is it ethical for me to open my window? I'm on the third or fourth floor, depending on how you count it, and throw that mug out the window in such a way that it might, not deliberately, but might hit a person who's walking down. I'm just going to callously toss it. There are people walking back and forth. Is that okay? And you could say, no, you might hurt somebody. You can calculate that that might hurt somebody. You could also ask, like, is it a styrofoam cup? Is it empty? All right, if it's styrofoam and empty, it's not great, but I guess, I'm not going to arrest you for it. I'm going to give you a stern talking to. You can reason about these scenarios. That's the answer to the toxic language problem, is you need a system that can reason about scenarios and think about the consequences of actions. Like, if I said this to a user, what might be the consequence? If I said, I think you should kill, I think you should, in response to the question, should I kill myself? They might actually do it. That's not a good consequence. And it's a little bit like the guardian guarding the guardians. You can't use a GPT-based system to guard itself against those errors, as it doesn't understand this stuff. Got to need something else.
So in some ways, the hybrid or multi-model approaches that you've been advocating for is not just a way of bringing the field forward, but also a way of making sure that we do it in a secure and safe way.
That's right. I mean, that was the whole point of rebooting AI, ultimately. The subtitle of the book was Building Artificial Intelligence We Can Trust. The whole point of the book is that the technology that we have now is not on a road to trustworthiness. It just isn't. And so we wrote that in 18, came out in 19. And now in 21, people are starting to realize this is an issue, but there's still mostly just, I'll make the street light brighter and somehow it's all going to work out. And I often get what I'll call the argument from optimism, which is sort of like, I kept adding more data and things were good, so I guess I'm going to solve the problem. And that's actually a bad inductive argument. An inductive argument says, because one form of inductive argument is things have always been this way and it will continue this way.
In February 2020, you wrote a 60-page long paper, The Next Decade in AI, 4 Steps Towards Robust Artificial Intelligence. Would you mind sharing with us what those 4 steps entails and their relevance for the future of responsible AI research and applications, and also as a means to avoid this sort of ethics washing that we just discussed?
The first step is neurosymbolic hybrids. We need them, systems that can represent both symbolic things like sentences, for example, and kind of neural network kinds of things, that they're useful for different things. The neural networks are very good at learning relations between individual features that make up an image, for example. We don't want to get rid of that. We might improve it. We might find a system that's like neural networks, but more data efficient. That would be great. But we're going to need something that plays that role that neural networks are playing now, of extracting collections of correlations from features and stuff like that. But we're also going to need something symbolic to represent all the world's knowledge, for example, that's in written form, all the sentences that we say to each other. And right now, the strengths of these two systems, the classic symbolic stuff that underlies pretty much all of the world's software, and the neural network stuff that underlies a whole bunch of technologies that have been recently invented, they're both useful, but they're complementary. The neural network stuff is good at learning, but it's terrible for abstract reasoning. And the symbolic stuff is great for abstract reasoning, but it's not so good at learning. There has to be better ways of putting those together. And we really have to cut this nonsense of mine is better and we don't need yours. No, we need both. Like that is to me non-negotiable. And I'm glad that there's been some progress in the field towards seeing that. There's still not enough. There's still people like Jeff Hinton that jump up and down in front of the whatever it was European Parliament and say, don't spend any more money on symbols. This is not productive. So that's step one. We also need to have large scale knowledge. And that was very popular in AI for a while. The most popular version, I think, was Doug Lennett's Psych system, which has not become what he had hoped it would be. But we need something like that. We have a lot of knowledge about the world and how it operates that we reason over. And these GPT systems use proxies for that, but it's not really there. So another example Ernie Davis and I had in a paper called GPT-3 Bloviator which should have been called GPT-3 artist, but the editor wouldn't let us do it. The point of that is that GPT-3 is a fluent spouter of bullshit, which means it can talk about anything, but doesn't really know what it's talking about. So we had an example where you're thirsty, you're thirsty, you have some cranberry juice on hand, but there's not quite enough, so you add some grape juice to it. And what happens? And GPT-3 says you drink it. That's good, and then it says you're now dead. Well, that's not so good. You don't really die from putting cranberry juice in grape juice. Humans do this stuff based on knowledge. So they know something like if you put two non-toxic beverages together, you get a third beverage that's not toxic. May not taste good, but it's not going to kill you. We know general purpose things like that. We know if you pour liquid into a container, if the container doesn't have holes in it, the liquid will probably still be there for a little while. We know all kinds of stuff about the world. And you can bloviate your way through that if all you're trying to do is make surrealistic dialogue. There's an application called AI Dungeon of GPT-3 that's very reasonable. You just say stuff and it says some other stuff, and we're kind of all playing a game together, and there are kind of no rules, and it's fine. But if you're trying to do medical advice, there are rules. There are ways in which physiology and toxicology and all these kinds of things, the way they actually work. And without knowledge, you cannot solve this problem. And then you need reasoning, which I think is not hard if you have the data in the right form. And I use Doug Lennett's Psych as an example. If you have the data in the right form, you can reason about really subtle things, like he sets up Romeo and Juliet, and then the psych system can reason about what happens when Juliet drinks the fake death potion and what people might believe as a consequence. We need that level of reasoning. In human interchange, we are constantly dealing with people, for example, that have different forms of knowledge or different knowledge available. Anytime you watch a movie, practically, there's going to be like a scene where one character knows something and the other character doesn't. And some of the tension is around that. We need systems that can reason about that. Or in real world politics, if you want to navigate a solution, it often helps to understand that people have different beliefs that lead to where they are, such that you can make a compromise. So we have to have much more knowledge built into our systems than these kind of blank slate systems that are popular now. And the last thing is you need a model of what's happening now. So when you watch a movie, you get introduced to different characters. You piece together their background and their motivations and so forth. If I'm talking to GPT-3 and it tells me that it's a person, okay, I'll build a model. Maybe I don't know because it's Chapa and it's over text messaging of it's a person. And then it tells me something else, then I notice an inconsistency. So I'm trying to assemble the information that I get in terms of an interpretation of the world. If I'm talking to somebody about their family, then I'm assembling an internal model. Okay, so they have 2 kids and this one's in school, and I'm trying to remember that and ask them questions about it and so forth. So we do a lot of building models of the immediate situation and almost any time we do any cognition. And these systems, again, they're not really doing it. So all 4 of these ideas are strongly grounded, let's say, in classical AI. And we need to update them in modern context. We need to take advantage of what deep learning can do, but not get rid of these 4 ideas because they're as foundational as they ever were. And our failures now stem directly from not taking them seriously.
I recall, Gary, that during a meeting held by the International Telecommunication Union in Geneva back in 2017, you referred to the need for a CERN for AI. You were essentially calling for an international AI mission to make sure AI becomes a public good rather than just the property of a privileged few. Can you elaborate what that entails in your view?
The impetus for the suggestion was that I think that some problems are too hard to be solved by individual investigators in classical labs and maybe just not central enough to businesses. I mean, in principle, Google has enough money, for example, to do whatever it wants, or Facebook has enough money to do whatever it wants, but they also have priorities, and their priorities are not necessarily the ones for society. Facebook's priority has been to get more users. They put a bunch of money into AI, but they make choices around how they do that. So part of it is the scale problem. The other is the public good side of it. So do we want, Google to figure out the answer to general intelligence and not share it with anything else? And what would be the consequence of that for society? So that's why I made this suggestion. And I have seen versions of that suggestion be taken up, but I think without the other thing that I think is central to it, which is there has to be a very shared mission that rallies a lot of people around a single problem, or maybe a small set of problems. What I suggested was language understanding for medicine as the rallying cry to build such a institute around. So the idea is we're still not that great at making medicine. And we have this enormous literature that goes unread. I don't know the exact statistics, but they're probably 1,000 articles published every minute or something like that. So most of them don't really get read. If we could have AI systems that could do more than just recognize keywords, so it's easy to build a system that will give me all the matches for COVID and DNA. That's not hard to do. But to get a system to read a scientific experiment, understand whether there's a control group, understand what was learned, and integrate that with another study, well, that would be amazing. And that's the kind of thing that no individual lab can do, no startup can do. It's too big. And Google might put in some money, but maybe not enough, and not directly enough. And so that's the idea, is that we could make foundational progress on AI on hard problems that require people to work together if we built such an institute. And I'll just give you one more thought there, which is it ties in with some of the rest of the conversation we are having and this notion of foundations, right? It ties in with the next decade article that we were just talking about. I think to succeed at a problem like this requires a large knowledge base that nobody wants to make by themselves. It requires neurosymbolic stuff, which there's been some incentive, but not enough incentive to build, and so forth. It requires synthesizing all of the things that we're talking about in a way that cannot be done individually, but could really make a difference in society.
And one of the big benefits, of course, of CERN, which in some ways is ethics in practice, is that you have this broad community coming together, scrutinizing each other's research, forcing some level of transparency, sharing experiences across various domains, and also removing some of the vested interests. So there's a natural kind of inbuilt ethical oversight into it.
Yeah, and I'll talk about one that's related, that's really that produces envy on my part, which is CERN is less ego-driven than I think a lot of scientific enterprises. People are part of a big machine. They get their publications and so forth, but people are really there for a common sense of mission. And you can't have something functioning like the LHC if every person's kind of like me. It has to be a little bit of me, but a lot of us. And I don't think we'd get to AI without that similar thing. I mean, you talked about, your background in anthropology. We need the right kind of anthropology / sociology to get people to commit to common goals, I think, in order to solve AI.
Well, we need scientific and anthropological intelligence. That's what I keep advocating for.
Agreed. AI is not magic. And I think that people who are in positions of power need to understand that. They need to understand that AI is actually a flawed collection of techniques, a flawed and immature collection of techniques, and that not all problems are equal, that some problems are easily solved by current techniques, some are well beyond current techniques. To make intelligent decisions, I think you need to understand, you have to actually dive into the details. You can't just treat AI itself as a black box. To make progress, we need to have a rich understanding of what's really going on. We have to cut through the hype, and we have to think about what collective good we want to achieve, and ask the relation between the tools that we have and the vision that we have for our future. In my opinion, there is a serious mismatch between the tools that we have, which are good at these big data analyses, but not good at deep understanding. There's a mismatch between those tools and the goals that we want of a just society. And we need to be aware of that mismatch and to think about how to solve it.
Which reminds me of an article that you wrote, I think 9 years ago, Cleaning Up Science.
I hadn't thought about that one in a while. Yeah.
So essentially what you're advocating for is to deal with the magnitude of both the challenges and opportunities we are collectively facing as we're embedding AI systems and algorithmic technologies and sensitive systems. We also need to clean up science to have that honesty and approach that you just referred to.
That's right. And I think in some domains, a reckoning came, and that's good. Psychology and medicine in particular, people realized there was a replicability crisis, and they've really tried to approach it. So as compared to when I wrote that 9 years ago, I was writing about something that was in the wind. I didn't invent it, but the winds of change came, and people, for example, now take seriously replicating studies, registering what's being done in advance. Machine learning needs to do the same stuff. Joel Pinot has written about this. It's still mostly a culture of, I published the one run that looks really impressive and not publishing all the data, like GPT-3. Here's a report of what we did. What else did you try? How does it compare with other possibilities? What if you just change the random seed at the beginning? Would you get the same result? There's very little of that, although it's starting to happen, but there has been too little in machine learning, I think, of two pieces of science. One is kind of candid disclosure. OpenAI is the worst. They have this name that sounds like they're open, and yet they won't let a scientist like me try out the model to see what's wrong with it. That's completely scandalous from the perspective of science. So you need openness, you need replication, you need to let other people have access, for example, to your database to see if they can replicate it. OpenAI doesn't give anybody that. So here's a question. How much of GPT's answers are plagiarized directly from the database? Basic question we should have an answer to. And nobody has an answer because the database is proprietary. So we don't know how much is just regurgitation. There are nice independent projects like Eleuther that are public projects that are trying to do some of the same stuff, but OpenAI is like at the absolute most scandalous side of this. You lack replicability, you lack openness, and so forth. And then the other thing that science really needs is for people to compare competing hypotheses. And if all you have is, took me $5 million to run it this way, I didn't run it any other way, and you can't run it either, how on earth are we going to make scientific progress? It's just not a recipe for success. Like, basic tenets of science are you share your data, other people try to replicate, you consider alternative hypotheses. Like, the kids today would say hello, like hello, yes. Those are the premises of science. Without it, you're lost.
So we need to learn from CERN and also open up a AI discourse where we encourage people to share limitations and share their research.
If we can get past people's egos and do science as it's meant to be done, we can solve AI.
That's a good final note. Thank you so much, Gary, for taking the time to be with us, sharing your knowledge and deep insights. Thank you to all of our listeners and the team at the Carnegie Council for Ethics and International Affairs, hosting and producing this podcast. My name is Anja Kaspersen, and I hope I earned the privilege of your time. Thank you.